Let us consider a question where one of the members of the Pythagorean triplet is given as 16. So, we can say the value of 2m is 16. We have to find out the other members of the Pythagorean triplets. So, 16 is one number which is given to us. We have to find out the other two. At the moment, we are using this formula 2m is 16 to find out the value of m. So, m becomes 16 upon 2. So, the value of m is 8. Now, to find the second and third member of this Pythagorean triplets, we are going to use the formula m square minus 1 and m square plus 1. So, m square minus 1 we will say 8 square minus 1 because the value of m that we had found out was 8. So, 8 square minus 1 we get 64 minus 1. So, we get the second member of the Pythagorean triplet as 63. What about the third member? The third member can be found out by using m square plus 1. So, m square plus 1 indicates the value of m is 8. So, 8 square plus 1, this is going to be 64 plus 1. So, we get the third member of the Pythagorean triplet as 65. So, in this manner we will be able to find out the members of the Pythagorean triplet if any one member is given. Another example can be taken. Let us say one number given is 12 and the others have to be found out. So, one member is 12, find out the other members of the Pythagorean triplet. So, using the same strategy, 2m is 12, m is equal to 12 upon 2, that is 6. Second number will be m square minus 1, third number will be m square plus 1. So, this is going to be m square minus 1, that is 6 square minus 1, 36 minus 1, that is 35, and here we get m square plus 1, that is 6 square plus 1, this is 36 plus 1, we get 37. So, we have the Pythagorean triplets as 12, which was given to us in the question, and now we have found out two more, 35 and 37. Now, this means that the biggest number 37 is actually the hypotenuse of the right angle triangle. In a right angle triangle, the hypotenuse is the longest side. So, this is 37 and the other two sides, that is the base and the perpendicular, are 12 and 35. So, this is 12 and this is 35, and if I take the square of these two and add it up, I will get it equal to the square of this hypotenuse, that is 37. So, in other words, 12 square plus 35 square will give me 37 square. Now, the next thing that we can do is to find out how many numbers lie between the square of two numbers. So, if we are having two numbers, let us say 3 and 4, and the question is how many numbers lie between 3 square and 4 square. Now, before applying the formula, let us manually find out how many digits are there. Now, we know that 3 square is 3 into 3, that is 9, and 4 square is 4 into 4, that is 16. So, the numbers lying between them will be 10, 11, 12, 13, 14 and 15. So, we have 1, 2, 3, 4, 5, 6 numbers between them. But when I subtract 16 and 9, I get 7. So, in order to find out the number of digits lying between the square of two numbers, we can subtract these two answers, and then once we get the answer, further subtract 1, we get the final answer, that is 6. Or there is a simple formula by which we can directly find out, and that formula is 2n, where n is the smaller number. So, here we find that 3 and 4 are the two numbers, the smaller number is 3. So, we get 2 into 3, that is 6. So, we can say that the number of numbers lying between 3 square and 4 square is 6. If suppose you are given a question, how many numbers lie between 10 square and 9 square? So, we have two numbers, 10 square and 9 square. 10 square is 100, 9 square is 81. Now, if I subtract this 100 and 81, we are going to get 19. Now, this 19 is actually not the answer, because if I count from 82 up to 99, it will be 1 less than this. So, if I want to find out the answer, 19 minus 1 is equal to 18 will give me the final result. Or as I told before, the formula can be applied, that is 2n, where n is the smaller number. So 10 and 9 are the two numbers given to us in the question. So the smaller number is 9. So this becomes 2 into 9 equal to 18. So this formula helps us to do the question faster, instead of actually subtracting and finding out and then subtracting 1 or counting the digits between 81 and 100. So we can directly apply this formula 2n, where n is the smaller number, and then we get the result. Another important property that you can observe when we take the square of numbers is that, as defined earlier, a square is obtained by multiplying a number by itself. So if you look at the trend, 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16, 5 square is 25, and so on and so forth. One interesting observation is that for all odd numbers, we have 1, 3 and 5 as odd numbers, the result of that will also be odd. So when I square an odd number, the result is also odd. So here we have an odd number, here also we have odd numbers, because 1, 3 and 5 are odd numbers. And if we look at the even numbers, the result is also even. So 2 square, 2 is an even number, the square of 2 becomes even. 4 is an even number, and when I square it, the result is even. So we can always say that square of an odd number is odd and square of an even number is even. Now to find the square of a number, we can of course multiply the number by itself, or we can use a method which is called the diagonal method. Now this is a useful method in finding out the square of a number. Now let us say that we have to find out the square of 32. So 32 square means 32 has to be multiplied by itself to get the answer. So what we are going to do is make a box, 2 by 2 box. This is consisting of 2 digits, so we will make a 2 by 2 box. That means it will have 2 rows and 2 columns. If it's a 3-digit number, we are going to use a 3 by 3 box. So what we can do is write down this number here, 32, horizontally as well as vertically. And then this is called the diagonal method. Make diagonals for each of these squares and start multiplying the numbers. So 3 multiplied by 3 is 9. So it's a single digit number, so I can write it as 09. 3 into 2 is 6, so I can write it as 06. Then 2 into 3 is 6, so this is 06. 2 into 2 is 4, so this becomes 04. Now look at the last diagonal, the number is 4, so I'll write 4 as it is. The next diagonal has 6, 0 and 6, so 6 plus 0 is 6, 6 plus 6 is 12, so I have 2, 1 carried over, 1 plus 9, 10. So we have nothing to carry over here because it's already 0 here, so 0, 1, so we get the answer as 1024. So this becomes a very useful method for calculation of squares. So 46 again is a 2-digit number, so I will make a 2 by 2 box. I am going to write 4 and 6 here and 4 and 6 out here, horizontally and vertically. Make the diagonals and start multiplying. 4 into 4, 16. So 1 comes here and 6 here. 1 digit has to be written per triangle. 4 into 6, 24. So I'll write 2 here and 4 here. 6 multiplied by 4, 24. So 2 here and 4 here. 6 into 6, 36. So 3 here and 6. Now start adding. The last diagonal is giving us 6. 4 plus 4 is 8. 8 plus 3 is 11. So 1 and 1 carried over. When 1 carried over, 2 plus 1 is 3. 3 plus 6, 9. 9 plus 2 is 11. 1 and 1 carried over. Already there is 1 there. So 1 plus 1 becomes 2. So I can say that the answer is 2116.